Sometimes simple linear regression and multiple regression on their own isn't enough to accomplish the goals that we have in mind for our analysis. And one approach we can take when we're not getting the results that we expect or we're seeing some issues in our output is to create interaction variables or interaction terms to fit into our model. So if you recall, our sample regression equation is y hat is equal to b naught plus b1 times x1 plus b2 times x2 and so forth. That's our multiple sample regression equation, where b sub j measures the change in the predicted value of the response given a 1 unit increase in xj, holding all other predictor variables constant. B sub j is also the partial or marginal effect of x sub j on y hat. Not to get too calculus-y on you, but this is the partial derivative. And this partial effect is not dependent on other predictor variables. Basically, the interaction effect in a regression model happens when the partial effect of a predictor variable on the response depends on the value of another predictor variable. And in these scenarios, we have to be careful because it does introduce an element of multicollinearity into a model. So an interaction variable is the product of predictor variables, and there are three types of interaction variables that we'll get into. The first is the interaction between two dummy or binary variables. The next is the interaction between a dummy variable and a numerical variable. And finally, the interaction between two numerical variables. And there are video examples demonstrating how to go about creating and interpreting all three of these types of interactions. So I definitely recommend taking a look at them. And all of those examples are conducted using R, so you might find that helpful. So when we're working with dummy interaction variables, say we have a model with two dummy variables, d1 and d2, and then an interaction variable, d1 times d2. So note that that interaction variable is composed of dummy variables d1 and d2. So we see that the partial effect of d1 on our estimated value of y is b1 plus b3 times d2. And this depends on d2. So when d2 is equal to 0, the partial effect of d1 on y is beta 1. But if d2 is equal to 1, the partial effect of d1 on the estimated value of y is b1 plus b3. This difference is because anything multiplied by 0, well, it's 0. And the same basic idea applies with the partial effect of d2 on the estimated value of y. We may also have interaction terms that multiply numerical by dummy variables. And again, it's important to remember that anything multiplied by 0 is 0. So if you're multiplying a numerical variable by a dummy variable, and that dummy variable, that d variable, is equal to 0, that interaction term in that scenario is equal to 0. But if the dummy variable is equal to 1 in that instance, it holds on to the numerical value of that variable at that value. So similarly, the partial effect of x on the estimated value of y is b1 plus b3 times d, but this depends on d, our dummy variable. So when our dummy variable is equal to 0, the partial effect of x on the expected value of y is b1 because anything multiplied by 0 is 0. But when our dummy variable is equal to 1, the partial effect of x on our expected value of y is b1 plus b3. The partial effect of the dummy variable on our expected value of y is b2 plus b3x, and it depends on x. But this can be challenging because x is numerical, and it's most common to interpret this partial effect at the sample mean x bar. At that sample mean, the partial effect of the dummy variable on the estimated value of y is b2 plus b3 times that sample mean. When b3 is greater than 0, the partial effect on the estimated value of y is going to be greater at values higher than x bar, and vice versa. And then finally, we have numerical interaction terms where both variables in the interaction term are numerical. They can be discrete or continuous. And the specific effect of x1 on the estimated value of y is b1 plus b3 times x2, dependent on the value of x2. Similar relationship applies with the relationship of x2 on the predicted value of y. And the partial effects of both variables are difficult to interpret. So I suggest you take a look at the examples that are posted to better understand how we can go about interpreting these interaction terms, as well as sort of getting a sense of when they may or may not be indicated. This is a tougher concept to wrap your head around, but sometimes it is exactly what you need to effectively analyze your data. So catch those examples, and I'll catch you next time.